Big data is an elusive concept. It represents an amount of digital information which is uncomfortable to store, transport, or analyze. It is so voluminous that it overwhelms the technology of the day and challenges us to create the next generation of data storage tools and techniques. So it isn't new. In fact, physicists at CERN have been wrangling with the challenge of their ever expanding big data for decades. 50 years ago, CERN's data could be stored in a single computer. Okay, so it wasn't your usual computer. This was a mainframe computer that could fill an entire building. To analyze the data, physicists from around the world traveled to CERN to connect to this enormous machine. In the 1970s, our ever-growing big data was distributed across different sets of computers, which mushroomed at CERN. Each set was joined together in dedicated homegrown networks. But physicists collaborated without regard for the boundaries between sets, hence needed to access data on all of these. So we bridged independent networks together in our CERN net. In the 1980s, islands of similar networks speaking different dialects sprung all over Europe and the States, making remote access possible but also torturous. To make it easy for our physicists across the world to access the ever expanding big data stored at CERN without traveling, the networks needed to be talking with the same language. So we adopted the fledgling Internet Working Standard from the States, followed by the rest of Europe, and we established the principal link at CERN between Europe and the States in 1989. And truly, the global Internet took off. Physicists could easily then access the terabytes of big data remotely from around the world, generate results, and write papers for their home institutes. Then they wanted to share their findings with all their colleagues. To make this information sharing easy, we created the web in the early 1990s. Physicists no longer needed to know where the information was stored in order to find it and access it in the web. An idea which caught on across the world and has transformed the way we communicate in our daily lives. During the early 2000s, the continued growth of a big data outstripped our capability to analyze it at CERN, despite having buildings full of computers. So we had to start distributing the petabytes of data to collaborating partners in order to employ local computing and storage at hundreds of different institutes. In order to orchestrate these interconnected resources with their diverse technologies, we developed a computing grid enabling the seamless sharing of resources around the globe. This relies on trust, relationships, and mutual exchange. But this grid model could not be transferred out of our community so easily, where not everyone has resources to share, nor could companies be expected to have the same level of trust. Instead, an alternative and more business-like approach for accessing on-demanding resources has been flourishing recently, and that's called cloud computing, which other communities are now exploiting to analyze their big data. It seems paradoxical for a place like CERN, a lab focused on the study of unimaginably small building blocks of matter, to be the source of something as big as big data. But the way we study the fundamental particles as well as the forces by which they interact involves creating them fleetingly, colliding protons in our accelerators and capturing a trace of them as they zoom off near light speed. The fact that we can derive more knowledge by joining related information together and spotting correlations can inform and enrich numerous aspects of our everyday life, either in real time, such as traffic or financial conditions, in short term evolution, such as medical or meteorological, or in predictive situations, such as business, crime, or disease trends. Virtually, every field is turning to gathering big data with mobile sensor networks spanning the globe, cameras on the ground and in the air, archives storing information published on the web, and loggers capturing the activities of internet citizens across the world. The challenge is on to invent new tools and techniques to mine these vast stores, to inform decision making, to improve medical diagnosis, and to otherwise find answers for needs and desires for today's and tomorrow's society in ways that are even unimagined today.